Thank you, Anima. My name is Prasad. Today I am dealing with a microprocessor, microcomputer, assemble language. The content of this topic, the 8085 microprocessor unit, microprocessor communication, bus timing, demultiplexing, bus 8002 to 87, generating control signal, 8085 architecture, injection, data format, data storage. Overview of the 8085 injection set. The microprocessor. The microprocessor is a general process unit with a H or a single chip integrated circuit has all that functional components of the CPU, namely as a arithmetic logical unit, control unit, registers. The 8085 microprocessor is an 8-bit processor that includes on its chip most of the logically circuits or the performing of the computing task and the communicating with a peripherals. The features of 8085 microprocessor. The features having a some features 8085 8-bit microprocessor, 80 microprocessor can read or write performing arithmetic and logical operations on the 8-bit data or data. It has 8 data lines and the 16 address lines. Hence, the capacity is a 216 to 64 kilobytes of the memory. Clock frequency is 3 megahertz. It requires 5 voltage power supply. It is a single chip NMOS device implemented with a 6200 transistor. It provides 74 instructions with a 5 other signals. It provides 5 hardware interrupts and 8 software interrupts. Interrupts. These features, where the I8085 microprocessor IC is fabricated. In this fabrication, it's some architecture blocks are there. The blocks name we are calling as an architecture of 8085. The other name we are calling as a fundamental blocks of 8085. Here, the first step we are using is the ALU timing and control unit, general purpose register, programming status code, programming counter, stack pointer, instruction registers, and decoder, interrupt control, serial IO control, address bus, data bus. Here we are using as a blocks. Different blocks are there. This is the block and architecture of 8085. Here the serial input or output control. Here the serial, while we are receiving the data from the serial, that serial input data, while we are transmitting the data in the form of the serial, that one we are calling as a serial out data. Interrupts are 6. Again, the interrupt controls are 6 blocks are there, 6 blocks are there. Interrupt receiver, interrupt acknowledgement, reset 5.5, reset 6.5, reset 7.5. These are the interrupts. What is the purpose of interrupt means? The interrupt purpose means the subprogramming of the program we are calling as a interrupt. Here the some blocks are there, registers blocks are there. In this register box, we are using as a accumulator. The accumulator, the purpose of the accumulator, the temporary storaging purpose. The temporary storages are there that will be not in use in the program, but with the storage we are using this one. The flag we are using as a 5 flags are there. But the 5 flags later we will discuss. Arithmetic and logical control blocks are there. Instruction register, instruction decoder, the machine cycle encoding, and the multiplexer. Here we are using as a gender arrays or gender registers, register array, register selection. Here there are 2 types of register: general purpose register, special purpose of register. Another block we have the timing and control. Here the timing and control, again the blocks are again sub blocks are there. Clock generator, controller, status, data memory, direct memory access, reset. The reset, and there is the blocks are there. Address buffer is there, data address buffer is there. The address buffer has consisting as a 16 lines. The data address buffer is a 8 lines. Here the programming modes of the 8085. The programming modes of 8085. The accumulator on the flag, B register, C register, D register, E register, H register, B register means base register, C register means port register, D register means data register, E register means extra segment register, H register means high order register, L register means low order register, The stack pointer is a 16-bit register. On programming counter, the programming counter, while you are executing the program, it will be counts the program that when you are calling as a program counter. Data bus 8 lines, bidirectional, it is a bidirectional. Address bus, it is having 16 lines, it is a unidirectional. The address lines, the 16 lines are there, we are having a D0 to D7 here, A0 to A7. Basically, the address bus have a combination of them, data lines and address lines. Here we are using as a registers. Registers are 8 bits and 16-bit sizes uses in the different purpose. Accumulator. The accumulator is a special purpose registers. All the arithmetic operations All the arithmetic operations are performed with the reference to the content of the accumulator. B, C, D, E, H, and N. General purpose register. These registers can also be used in the system bit operation in the pair. When we are using the pair, consisting of system bit. When we are using in a single consisting of 8 bits, the default of the pair B, C, D, E, and H, N. If we take as a only B, it consisting as a 8-bit register, 8-bit register operation. Flag register. The flag register is indicated the status of the ALU operation. And also we are also called as the supporting of arithmetic logical unit with the help of the flag registers. Here the flag register is consisting of 8 bits, but we are using as only 5 bits only we are replacing. That was the D0 is the carry flag, D2 is the parity flag, D4 is the auxiliary carry flag, D6 is the zero flag, D7 is the sign flag. Here the PC, the program counter, this is a 16-bit register used to address memory location for where an instruction is going to be executed. Stack pointer. This is a 16-bit register used as an address the top of the stack memory location. Temporary register. These registers are only used by the 8085 and are not available for their programming. The arithmetical logical unit, the arithmetic logical unit performing of 8-bit arithmetical logical operation. These operations are generally performing with the accumulator as one of their operands. The result are saved in their accumulator register. While you are not giving any extra more register, then it will be stored directly in the accumulator. If you give any of the other register, it will be stored in the general purpose register, whatever we give. The timing and the control unit. This is the unit works with the by brain of the CPU and is generating all the timing and control systems to performing all the internal and external operation of the CPU. The instruction decoder of the machine cycle encoder unit. This unit is a decoding of the output storage in the instruction registers and is encoding it is for the timing and control unit to performing of the execution of the instruction. The flag register. This is the flag register among we discussed. The flag register is the group of 5 flags, 5 flip-flops used as known as a status of the various operations done and is given by the zero flag, sign flag, zero flag, auxiliary carry flag, parity flag. When we are using as a carry flag, suppose we are doing as a arithmetic operation, arithmetic addition operation. We are doing a suppose taken one operand A value is 1101. The B value is in all ones. Suppose 1 plus 1. 1 plus 1 means we are getting as a sum is a 0, carry is 1. That the extra bit, the carry bit will be carried by the carry flag. The carry bit will be carry flag. The auxiliary carry flag, the label of the fourth bit, of the operation, that extra carry bit we are calling as a auxiliary carry flag. Parity. We have the 2 types of parity. The even parity, odd parity. Even number of ones we are calling as even parity. Odd number of ones, if we get as odd number of ones, we are calling as a odd parity. The zero flag is set as a result as the operation is a 0. That one we are calling as a zero flag. Sign flag. The sign flag is a representing of the result of the either the value is positive value or negative value is represented by the sign flag. This is the supporting of all the arithmetic operations we are used here.